Hey everybody, I wanted to make a quick video, hopefully quick, or 2 videos of the free response questions from 5 Steps to a 5 that you were assigned yesterday. So I'm going to go through my solutions and how to use the formula sheet really to help us out. At least for now, the formula sheet that I provided that gives you tons of details. When we get closer to the exam, we'll look at what details we need to memorize and what details we have. But for now, you can really use any resources you have. So I'm going to go ahead and bring that formula sheet up. So here's that formula sheet I was talking about. If you notice, as formulas down the left column, most of them are supplied on the AP exam. So for example, these first 4 right here are on the AP exam. What's not on the AP exam are the calculator steps in the middle column, and then here the interpretation in the last column. So let's see how these formulas work in these FRQs. So the first question, given a 2-variable data set such that x bar is 14.5, y bar is 20, sx is 4, sy is 11, r equals 0.8, find the least squares regression line of y on x. This is actually a very easy problem. Again, look at my formulas. These first 3 formulas involve, well, 1, the least squares regression line. The other 2 involve the information I was given, and what I need for my regression line is A and B, and these second 2 formulas will supply that. So you don't have to memorize these formulas, they're on the exam sheet. So to find the B, I'm going to have to find the B first, the slope. I'm going to do R times SY over SX. So for this problem, the slope is going to be R times SY over SX. Again, that's on the formula sheet, you have it. And I'm just going to go ahead and type those numbers in the calculator. For us, that is 0.8 times 11 over 4. And I get 2.2. And then I'm going to use that second formula. Again, will be given to you. Y bar equals A plus BX bar. It's on the formula sheet. Oops, sorry, A plus BX bar. And I'm going to plug in Y bar, X bar, and I just found B. And I'm going to solve it for A. So that's going to look like 20 equals A plus 2.2 times 14.5. I'm going to put that in the calculator. So I'm just going to do it all at once. 20 minus 2.2 times 14.5. I'm just going to do it all at once. And I get negative 11.9, so that's my y-intercept. And I have my regression line, y hat equals A, so negative 11.9 plus 2.2x. Didn't ask me to interpret. Sometimes it'll ask me to interpret. I think we'll get to a few of those in a little bit. All right, the second FRQ, number 3, the following is a residual plot of a linear regression. A line would not be a good fit for these data. Why not? Is the regression equation is the regression equation likely to underestimate or overestimate the y value of the point marked with a square? So let's talk about why it's not a good fit. The biggest reason it's not a good fit is there's no equal spread on either side as you go across from left to right. So I look at these x values. I don't have equal variation. Another reason is there's a pattern, a linear pattern actually. Linear patterns are good on a scatter plot, but they are bad in a residuals plot. So I don't want to see any straight line or any curve. A good residuals plot would have points up here where my little pen is and down here where my pen is. They'd be equally scattered. The second thing it asked about this black box, well, think about it. If this residuals plot, observed minus expected, a residual comes from observed, y minus expected or predicted y. Take a second and think about what does that mean? I mean, if the observed minus expected is above 0, so if I subtract observed minus expected and I get a positive number, that means the observed was higher. So my expected or my predicted is actually an underestimate. So this means the observed value is greater than the expected, or my model would underestimate the y values. Next question you were assigned was number 6. A study found a strongly positive relationship between the number of miles walked per week and overall health. A local news commentator, after reporting on the results of the study, advised everyone to walk more during the coming year because walking more results in better health. Comment on the reporter's advice. And one thing I gotta say here is association does not imply causation. We stressed that first semester. Still holds today. So just because there's an association, I cannot claim cause and effect. So I can't say that walking makes better health. You people that walk more, maybe they eat healthier. Maybe they work less, so they're less stressed. They have more time to walk. There's other things that could be going on in the background that cause the association. I cannot say that walking causes better health. A little bit more work here in this next one. Consider the following data set. Given the least squares regression line for these data, so here's my regression line. What is the value of the residual for 73? The point 73, 7.9 above or below the regression line? Well, remember, a residual is going to be observed minus expected or observed minus predicted. Or even easier, let me just write y, the actual y, minus y hat. So here's my formula for residual. Well, the y value, I just look at the table. When x is 73, the y value is 7.9. And then to get the predicted, I'm going to have to use the equation. So I'm going to have to put 73 in for x in this equation to find that predicted y. So it's going to look like 26.211 minus 0.25 times 73. That value ends up being, when I subtract, I get a residual of negative 0.061. If you calculate that, I already calculated it. So there's my residual, and then I asked, is it above or below the regression line? Well, the actual point, if the actual observed minus predicted, if I get a negative number, that means the predicted value was bigger. So the line was above the actual point. So here, the point falls below the regression line. 7.9 is below this y value. I didn't calculate this, but you could easily just type in what's in blue. That would show you the predicted y value. So again, the actual point falls below the regression line. 7.9 is less than whatever that blue value would be. This next question, I just included it because it's a little bit weird. I've never seen one quite like it on the actual AP exam, but I figured you guys would struggle with one like this. Suppose the regression equation for predicting success on a dexterity task y from the number of training sessions x is y hat equals yada yada, and that sy over sx is 3.33. What percentage of variation in y is not explained for regression on x? So this sounds a lot like coefficient of determination, or r squared. Remember, r squared is the predicting power of the model. So I don't really know where to start. I mean, I don't see r, so I can't just square r to get r squared. Let me go back to my formula sheet. And let me look where I see sy over sx. Let me double check. Sy over sx. And I see it right here in this slope formula. So keep in mind, they gave me the line. So I have slope, I have b. They gave me sy over sx. So I'm just going to solve that for r and then square it. So b equals r times sy over sx. So I have most of these values. B is 2.7 equals r. Sy over sx I was told was 3.33. And if I solve this for r, I get r equals 0.811. And easy enough from there to go ahead and square r. If I square 0.811, I get 657. Now this would be the percentage that is explained by the regression. So this would be the percentage of variation in Y that's explained by the regression on X, by the model. And I want not. Well, guess what? Just 1 minus R squared is going to give you what it asked for. So if I do 1 minus 0.657, I got 0.343. So I would say 34.3% of variation in Y is not explained by the regression on X. Very common on AP exam questions is, what do you do if you remove an influential point? That's what this one's about. It says, here's a scatter plot. The highlighted point right here is both an outlier and it's influential. Describe what will happen to correlation and the slope of the regression line if that point is removed. So notice I have these points down here that are in a linear pattern. It looks flat, but I'm guessing the window is a little bit changed because of this outlier, this influential point. So if I remove that, you have to think, what's going to happen? Right now, the line, it's influential because it's affecting the line. Right now, the line is being pulled towards it. Like, I'll do a dash line, maybe something like this. That point's pulling that line up. And if I remove it, well, then I'm going to be more linear. The pattern will look like this. Sorry, it's not too straight. But what's going to happen is, one, the correlation is going to increase because it's going to be more linear. That point is making it less linear. Two, the slope will decrease. Notice here the line was pretty steep. The slope's going to kind of flatten out. So the correlation will increase and the slope will decrease if that influential point removed. All right, I skipped number 13. I'm going to make a second video of number 13 because it's similar to the FRQ that you're going to be assigned today. So let's just jump to 16 real quick. So in 16, it says estimate R, the correlation coefficient for each of the following graphs. So let's just review what R ranges between. And your answers are going to vary here. So when I post my answer key, you don't have to the same R that I do, but correlation can go from very strong or perfect negative all the way to over here, very strong, perfect positive, and any degree in between. So the closer to zero, the less of a correlation or the less of a linear pattern. The closer to -1 and 1, the stronger the linear association. So when I see a R scatter plot in like A and I picture putting a line through this data, well, that's pretty strong and it's positive because it's increasing. So I would say anywhere from 0.5 to 1, somewhere in that range would be a good estimate of that correlation coefficient. If I look at B and I try to fit a line to that data, I mean, your line probably would be a flat line. There's going to be no linear association here. So I'd literally put 0 for my association, or sorry, my correlation coefficient for B. C, these points in C are perfectly straight. And if it's perfectly straight, that means you have the most positive correlation, or sorry, the strongest correlation, not positive, because here I'm negative, I'm decreasing. So I would say -1 for sure. And I'd say 0 for sure in B. And then D, it's negative for sure. It's definitely negative, but it's a weaker negative. I'd say something in this range. Any correlations between maybe 0.1 and -0.1 and like -0.5, -0.6 would be pretty good guesses.